this video, we are going to see the isostatic pressure, especially old isostatic pressure. So, it is a material processing technique in which high pressure is applied on the powder material for metal powder in a sealed elastomer container shaped for the applications. The powder is converted from a loose aggregate into a partially dense compact that has sufficient grain strength to permit careful handling and transfer to the following process operation. Compact pressure ranges that is nothing but 207 to 404 megapascal, although at high pressure up to 758 can be used. Then compaction is performed at an ambient temperature. The density of this loose powder poured into the elastomer mold is increased from 55 to 65% of critical, a normal range of uncompressed powder, to 75 to 80% of the 100% of the theoretical density value of the metal is being processed. Then next, the metal powder is compacted uniformly in all directions. Okay, due to that, so that what will happen? Compact becomes an accurate scale down of the mold. Uniform density we can achieve under the with the help of the micro and also the homogeneous microstructure also we can achieve. For this purpose, the powder is sealed in a flexible envelope and the assembly is immersed in the fluid which is pressurized. There are virtually no residual stresses in the compacted material because there is no die wall friction. Then, why isostatic pressing? To get a uniform density and compaction, to make a intricate shape or complicated shapes, to get object with great dimensional tolerance, to get homogeneous structures, then for the use of formers and the use of containers with holes for support purpose. Then in the cold isostatic process, two methods are used. One is nothing but the free mold, okay, or wet pack process. This is suitable for batch scale production. Then the mold is filled and sealed outside the pressure vessels. After the mold is introduced in the pressure vessel, then usually water is containing lubricating and corrosion preventive additives. Then complex parts can be developed. Research and prototype works. That type of products we can develop. Then several molds in one or even with differing shapes, that is parts of different sizes and shapes that require the same process parameters can be pressed in the same cycle. Here you can see the powder filled by the weight or volume. Then there is something but A is showing powder filled by weight or volume. The powder will be available in the circuit. Filling of the mold from the top. Here you can see the filling of the mold from top. Then C, the top lid put, okay, on the mold container. The top lid put mold container. Then the mold this is the mold completely that be kept inside the pressure vessel. So after that, what is the top lid of the put pressure on the vessel after necessary evacuation and filling with the pressuring medium. Then the top lid removed after required isostatic compaction. After the process, it will be removed. Here the pressure will be applied. Then after this process, the compaction, the isostatic compaction process, the top lid will be removed. Here you can see this is the process. Okay, then you can get the required shape. Okay, then next process is nothing but dry mat process. First one is wet bag process, then one is dry mat process, which is characterized by envelope is permanently fixed into the pressure vessel. After the elastometric mold is filled with the powder, pressure is applied by introducing the pressurized oil between the fixed mold and the vessel wall. Only one compact at a time is used. More simple shapes are made and more suited for mass production and faster production rates. Then here you can see this is the thematic equivalent of dry bag isostatic process. Okay, here you can see this, some of the preservation, some of the capital even in the process. Okay, the advantages of the cold isostatic pressings are highest safety, then outstanding cycle lifetime, then superior process control at all pressure levels, programmable pressure distribution with good accuracy, reduced mechanical stresses of processed material, lowest weight of the machine, process optimization, and improved functionality. Then the disadvantage of the old isostatic processing are slower than uniaxial pressing. Components may be required post-processing. The application, next we are going to see the application of the isostatic processor. Titanium is the example. Here, example hydraulic aircraft fitting using titanium powder and aluminum V master alloys powder can be developed. Okay. Then high-speed tool steels, example cutting tools. After that, compact with the interior threads. Okay, compact with the interior threads we can develop. Long hollow cylindrical fitters can be developed. Large ships from the tungsten powder such as rocket nozzles can be easily developed. Then tungsten and molybdenum tools or slabs for further forging or rolling alloys can be developed. Then cross section of molding bags. Here you can see this is the picture showing cross section of the molding bags. Then the body armor. Body armor they were developed with the help of the above process.